Okay, I see some people are still joining, but we're going to try to stick to the schedule, at least for the first session, even though it's very early morning for everyone. So good morning, everyone. My name is Cauchard. I'm an assistant professor at Ben-Gurion University of the Negev in Israel. So it's a little bit warmer for me than for most of you right now. But I'm really excited about sharing this session. We have 3 papers that are going to be presented, and 2 of them have honorable mentions. Honorable mentions are the top 5% of the papers at CHI, so it's very impressive. So congratulations to the authors. This is fantastic. We're going to start with our first presenter. So the paper is by Dimosthenis Kontogiorgos, and the work is on embodiment effects in interactions with failing robots. Dimo, do you want to maybe start your video?
Yeah, thank you.
Wow, it smells great, but I hope it tastes good too.
I hope so too. How many carrots was it again?
Sure I can. What kind of music would you like to listen to? I can really recommend a new Beatles collection.
No music.
Have you ever heard of the Beatles?
Voice control interfaces have changed profoundly the way we interact with technology. However, they are bound to fail in the interactions with humans. These failures can be critical because they require costly human intervention and can cause users to lose trust. Most research approaches start with the assumption of flawless interactions. However, as conversation is the main interface, visual feedback may not always be available. Users typically expect an interaction in an orderly fashion. In this paper, we use a set of failures informed by taxonomies of failures in previous studies in HRI. The induced failures represent typical robot malfunctions that have been reported in human-robot interactions. They were either task-oriented, such as giving incorrect guidance, or failures that violate social protocols of interaction. All failures have the consequence of delaying users in completing a task. The failures we used were the following. In this failure, the system simulates losing user engagement and restarts the interaction. After the failure has occurred, the robot becomes responsive and continues the guidance. And sample user response to the failure follows.
We have already started. We have already started.
In this failure, the robot time speeds improperly by producing an incomplete instruction, and after a short delay, continues its utterance.
Next, take the
what?
mushroom and add it.
In this failure, the robot simulates lack of user speech input by not responding for 20 seconds.
I'm done. What is next? I'm done. I'm done. What is next? Oh, this is not working. I'm done.
Take 1 spoon of red cabbage and put it in the spring roll.
In this failure, the robot repeats a previous statement by asking the user to perform again the previous instruction. And finally, in this failure, the robot produces an erroneous instruction by asking the user to pick up a non-existing object. Using the failures above, we asked human users in this corpus to engage in a referential communication task. Users were instructed how to cook spring rolls by 2 robots. Spring roll recipes were broken down to interaction segments and used for instructions. The recipes were non-trivial, so users had to interact with the robots to successfully complete the task. Interactions were segmented into dialogue acts, and the robots would reply to clarification questions from human users. Users were not instructed on dialogue options, but had to interact with the agents to find out. Participants were led to believe that robots were autonomous. However, to dismiss technical problems, we used a human operator. There is a long-standing effort in bringing human likeness to robots, but how robot embodiment affects users' behavioral responses to failures remains largely unexplored. Smart speakers and human-like robot embodiments, for example, differ in interactional affordances, from transactional to relational interactions. While robot embodiment has shown to typically positively impact human-robot interactions, it remains to be explored if this effect persists when the robot fails. The robots we used were the following. An Amazon Echo device that used voice as an only output modality, and the fair hat robotic head for the human-like robot embodiment. Time-critical situations are difficult to convincingly simulate in the lab. As such, most studies have focused on robot failures where little is at stake. In this work, we introduced a time pressure to half of the participants using a timer on the screen. We expected that under time pressure, the same failures would have a higher severity on the task. We therefore separated failures to low severity failures, little to no consequence of the failure, versus high severity, more severe consequence of the failure, respectively. Participants under time pressure were told that they would receive double the reward if they would finish the task on the top 20% fastest of all previous interactions. The robot's failure would delay participants, decreasing their chance of doubling the reward. At the end of each task, the experimenter would enter the task room, inform participants that their task time was not on the top 20% and that they should proceed with a post-task questionnaire. At the end of the experiments, participants were debriefed that this was part of the study manipulation. In a user study with 44 participants, we investigated the impact of these two different factors. One is robot embodiment, and the other one is failure severity. We used a set of behavioral and subjective measures to investigate the effects of embodiment and severity. Since we manipulated time pressure across conditions, we extracted the total task time with each robot. We expected that high severity participants would be faster, when an anticipated reward was at stake, rather than low severity participants. We segmented frames of each interaction into failure and no failure. In these time segments, we extracted temporal measures from users' multimodal data in gaze and speech. Using motion capture, we collected participants' gaze as informed by their visual angle and measured proportional amount of gaze towards the robot as well as the number of gaze shifts. We transcribed the corpus and extracted the number of words spoken and also extracted users' time to respond to a robot instruction. Before interacting with each robot, we asked participants whether they would like to use the system regularly. The question was repeated at the end of the interaction with each embodiment, with the goal of comparing before and after results across conditions. To compare levels of trust across conditions, we used two questionnaire items coded into 7-point Likert scale items. And to measure the level of intelligence that participants attribute to our robots, we extracted two questionnaire items from the Godspeed questionnaire. Finally, we measured the perceived social presence of each robot, which can be described as the sense of being with one another. We used 4 dimensions of the Network Minds Social Presence questionnaire. We divide each of the four dimensions into the 2 distinct directions of social presence, perception of self and perception of the robot. We observed that the manipulation of time pressure caused a significant effect on the task time with the robot. Participants spent less time in the high severity condition than in the low severity, showing that in time pressure they were indeed rushing to finish faster the task. Analysis of variance showed significant main effects in gaze in the factors of embodiment and failure. Proportional gaze to agent is higher with a human-like embodiment, HL, in the graph, but also generally higher when failures occur. We also saw that participants under time pressure shifted their gaze less frequently under no-failure cases, however, more frequently when failures occurred. Similarly, but in the direction of the smart speaker, 3-way analysis of variance showed significant main effects in embodiment and failure. Subjects uttered more words, therefore more complex utterances, with the smart speaker, but also when failures occurred. Furthermore, while users' intention to use the human-like embodiment keeps constant across time, intention to use the smart speaker decreases drastically after the interaction. Here, no significant effect was found on failure severity. Regarding trust and perceived intelligence, 2-way ANOVAs showed no significant effects regarding our main trustworthy item. All of the other items were significantly higher when users interacted with the human-like robot. Social presence dimensions from the direction of the perception of the robot were rated higher in the human-like robot. Conversely, in the direction of self, only the co-presence dimension was rated higher in the human-like embodiment. In the same direction, however, we found an interaction effect in the message understanding dimension. That is, in low-severity environments, users have an easier time understanding the human-like robot, where in high-severity environments, users have an easier time understanding smart speaker messages. Users considerably changed their intention to frequently use the failing smart speaker. This effect was not found for the human-like robot, suggesting that the human-like embodiment may mitigate the effects of failure. Additionally, higher level of intelligence and competence were ascribed to the human-like robot, even if it failed as often as the smart speaker. Participants did not consider that they allocated more attention to the robot according to the social presence measures. The behavioral data, in contrast, indicate that users do change their behavior with a human-like robot. Intuitively, participants are unaware of their increased attention and behavioral dependence, yet they still exhibit reactive communication traits typically seen in face-to-face communication among humans. Nevertheless, these findings indicate that human likeness is not always favorable. In time pressure, users appear to be distracted by the human-like robot. It is likely that the robot may distract the user from the task by displaying additional social behaviors, as more attention needs to be given to the system. Robot embodiment seems to affect how users will interact with the robot, and therefore also how they will respond to failures. Users seem to be more sensible to failures when they are interacting with smart speakers. Nevertheless, designers should consider the nature of the task. In high-severity situations where a high error rate is expected, non-anthropomorphic designs may be beneficial. Where time is critical, designers might want to avoid systems that benefit from the interpretation of social cues, as users may be distracted by the system's social behavior. Social interaction is afforded in robot design, and will lead to expectations of the robot's social behaviors and how users will respond to failures. Future research should focus on how these findings can be best applied to the design of assistive robots that will inevitably have to deal with failures and uncertainty in interactions with humans. Okay, thanks everyone. That was the end of the video.
Thank you. I think everybody can clap. So either physically or you have a little button to clap. Thank you. If you have any questions, please add them to the group chat or just put your name and then you can speak. Do we have any questions? We have about 10 minutes for questions, so don't be shy. I know it's early morning. I'll ask the first question, but I am definitely expecting more questions to come, even though it's early. So I found the work super interesting. It's there's been a lot of work on the uncanny valley phenomenon and how people, because you're talking a little bit how people found it a little bit creepy or something. Like, how do you think this would affect your work? Like, if you had to go along the uncanny valley in terms of anthropomorphism?
Right. So you asked how is the uncanny valley relevant to the effects in differences in anthropomorphism. So I think. So what we saw is that typically there's of course a novelty effect. So typically users have interacted before with the smart speakers, but of course robots are research prototypes. So we see that many times they're a bit surprised, or they have this eerie feeling when they start interacting with the device that of course can look at them and have some sort of contingent behavior. But so from some of the open-ended responses that we had, it seems that this type of feeling disappears after a few minutes.
Okay,
but it is there, definitely. Yeah.
Thank you. Kia has a question.
Yeah, hi.
Hi.
Failures are always interesting, aren't they? But
Yep.
What is confusing to me is that since I was in this area a long time ago, we have still not gotten any further. We've known about these issues for such a long time. So why is it that we're not progressing? I don't understand this. And what would progress be if you were to characterize that? So, you know, the uncanny valley, the media equation, the work early on about anthropomorphism and the issues with anthropomorphism and so on. Surely by now we should have some theory, some good ways of designing and so on, and still we're here struggling still. What's going on?
Right. Yeah, that is correct. So there's been of course a lot of research in especially in HRI already from the 80s and 90s. However, mainly focusing on work, for instance, that supports this idea that anthropomorphism is typically better. So of course that's not necessarily the case. So what we see here, of course, and what other HRI literature has pointed to is that not all devices have to be anthropomorphized. So not everything has to have a human face. And of course, you wouldn't want any device you interact with to either to speak to or to look at it and what we see here is basically that it differs how, rather than focusing on interpreting and generating social signals. So in that sense.
Well, 80s, to be honest.
Right.
It's like we keep asking this question, we keep asking about swearing at robots and all of these things, and it's like, yeah, we need to just, to come further is what I think. But anyway, I'll let the others ask questions.
We have a question from Aska.
Yes, thanks for a great talk. So I was wondering, like personally, if I had to deal with a robot that failed, I would probably be really frustrated and shout or get very angry. But I suspect some users will take these failures more lightly. Could you say anything, even just like anecdotally, about different personality traits and how these afford the frustration levels and how this interplay with the human likeness of the robot?
Yeah, so one of the things we also did was we asked participants for the big 5 questionnaire before they came to the experiment. So we had some measures of, for instance, extroversion or agreeability, etc. So from an anecdotal point of view, what we saw is that more introvert personalities, they want to not be confronted with a failure. So they try to avoid any failure by making sure that everything is right. While more extroverted personalities, they were trying to be more risky in that sense, to leave space for failures that can be resolved through dialogue. So in terms of more quantitative measures that we could compare, we saw at least that in differences in personality, extroverts and introverts extroverts asked more questions. So they were, of course, they had to resolve the failure, and they had to use social dialogue to do so.
And did you find an effect versus the robot and human like?
No, this one we didn't. No.
But you could expect that people who are more introverted, for instance, would prefer failures from a
smart speaker.
Yeah, what do I know? Something like that.
Yeah, this one, no, there was no effects in personality in that regard.
All right, thanks.
So we have time for one more question. If anybody has one quick question. Okay, I'll ask another one quick question. So you have a very heavy setup in the video with a lot of captors and sensors. And so did you find it was worth investing so much time and effort to go through all these different data? Or did you find that some channels maybe like a better way to measure the data? And would you recommend going for such a heavy setup, or would you recommend going for maybe a lighter setup that may be a bit more realistic as well, but giving you different data?
Yeah, I think, of course, you have the most basic setup one can have is a video of participants where you can use qualitative analysis for what is really happening in really microscopic levels in the interaction. And that, of course, you can do with no sensors, just by analyzing the interaction on conversational level. So what these sensors do, even though they complicate the setup a lot, is that they give us some sort of automatic way to describe the interaction. But it's true, it can be quite it can take quite a lot of time to just put things together and synchronize all different streams, of course. But I would expect one can do the same thing with only a video recording.
Okay, well, that's great. Thank you very much. Again, if everybody can applaud. Thank you. And our next speaker is going to be Sara Eriksson. Do you want to start sharing your presentation?
Yes. Hello, thank you everyone for being here this early. I'm gonna share my pre-recorded presentation. Let's see.
Hello, thank you so much for being here for this talk. My name is Sara, and I'm honored to be presenting our work, Ethics in Movement, Shaping and Being Shaped in Human-Drone Interaction, on behalf of myself and my co-authors, Kristina Höök, Shusterman, Svanaes, Unander-Scharin, and also Unander-Scharin. And the drones that I will talk about today is the aerial robotic choir, and it's a choir of 5 drones performing together with human dancers and singers in real time in an opera performance commissioned by the Croatian National Theatre in Rijeka, Croatia. And the opera is created by composer Unander-Scharin and choreographer Unander-Scharin, who you see here in the video snippet performing together with the drones. And the way it works is actually quite simple. So an optical motion capture system keeps track of the position and rotation of the drones and the dancer. And the drones are continuously sent new positions in space that they move towards based on the dancer's arm movement. And they do this while at the same time trying to avoid other drones, the dancer's body, and the walls defined by the motion capture system. So we have followed the creation or the process of creating the drones and the opera from the early development phase up until the rehearsals before the work in progress premiere last year at the Opera House. And one of the things that we noticed was that the choreographer was not only redesigning the drones to make them more expressive, but she would also change her own body and behaviors to be able to dance with them. So why is this interesting then, and what does it have to do with ethics? So as we already know, this is not something new, but the specific design of any technology, like the drones in our case, will encourage certain types of movements and experiences, and they will encourage certain types of practices and responses, while at the same time discouraging others. And thereby they contribute to sort of transform the way that we think and feel and engage with the world. So rather than some external system of moral rules or abstract principles, we'll draw on feminist care and situational ethics to understand ethics as something that we do and experience and negotiate in interaction with other people and our environment, including technologies. So as designers, we have a role here in shaping the interactions and movements that we invite our future users to engage in. So in this study, we ask, how can we approach ethics in a way that is generative for design and that takes into account our bodily engagements and felt experiences with technology? And to explore these questions, we'll turn to some aesthetics. And some aesthetics is interesting to us as designers and researchers because it's not only an analytical, but also a pragmatic and practical approach. And the idea is that by really attending to all of our senses, we can improve the understanding and use and experience of the body to increase our somatic awareness and ability to care for ourselves and others, but also to expand on the repertoire and the richness of our bodily experiences to improve on our ability to act in the world. So in this project, we use some aesthetics to understand how ethics is enacted in the artistic process of crafting the aerial robotic choir for the opera performance. And we did this through a combination of observations and researchers' first-person engagement. So the video snippets you see here, you see the choreographer to your left, dressed in black, dancing together with the drones. And you see me as a researcher to the right, dressed in orange, dancing with the drones. So data was captured through video recordings and field notes and was then followed by a video analysis. And we paid specific attention to moments where creative or somatic insights seem to arise. And I will discuss the results starting from one of these creative situations that occurred between me and the choreographer and the drones. So one specific movement adjustment that the choreographer had made was to be able to move the drones in a curved shape in space. And this was a movement that she found to be really expressive and evocative, especially when it was performed in a sort of slow and suspended way. But to do this movement actually required some knowledge about how the system worked, Because if you move your arm too fast, the drone would only register the last position and then take the shortest path to get there. So it would move in a straight line instead of a curved. But the choreographer wasn't really aware of that she had coordinated or changed her body movements to be able to achieve this curve, or how, until she saw me interact with the drones. And in the two video snippets here, you can actually see the difference between us performing with the drones. So to the left is the choreographer Åsa dressed in grey, and then you see me to the right dressed in orange. And you see how gracefully the choreographer moves with the drones and makes this curved shape. But I'm super tense and I'm really scared to move. And this is because if you haven't learned to coordinate your movements with the drones yet, and if you can't sense their responses, it's super scary to move with them. And it's actually even a little bit embarrassing because you know that you're not really giving an aesthetically enjoyable performance. But anyway, so when seeing me perform with the drones, the choreographer could sense how she had changed her body. So it made these sort of implicit and habitual changes explicitly available to her. And as she learned more about her somatic reactions, she could also reflect on some of the ways that the drones imposed or encouraged certain ways of moving. And that also opened up for new opportunities for design. But so in becoming more aware of how she had changed her body, the choreographer also became more attentive to mine. So in the snippet that you see here, she's using her sort of bodily knowledge and skills to teach me how to achieve this curved movement with the drone, both technically and aesthetically. So she's saying to me that it's not just about moving your arm from one position to another, but that you have to really engage in and explore the movement itself. And she's saying that you really have to sense the suspension of waiting for the drones to respond, and then to really feel how your arm movement continues in the drone. And while this way of moving is of course required to meet the aesthetic aims of the scene, it's not really about controlling how I perform with the drones, but it's actually about care. So she's teaching me how to find a connection with the drones that allows me to explore my own ways of being expressive with them. So the choreographer's self-cultivation here allowed her to attend to and to care for the experiences of the performer, but also the drones, and to improve the performance for an audience. And when it comes to the drones, even though it could be really scary to move with them until you felt you had a connection with them, embarrassing even, as for me, and even though finding that connection actually required you to adjust your own somatics to their programmed restrictions, the choreographer wasn't really looking to control the drones or have them sort of mechanically follow her, but their sort of own weird behaviors and strange bodies actually offered her a form of resistance and friction that inspired her to explore new types of expressions that the two enabled together. So the drones in this way contributed to expanding the choreographer's repertoire of possible movements and experiences, and thereby contributed to a sort of artistic freedom of choice. So what I want to point out here is that ethical self-cultivation and care is not always about engaging in experiences that are sort of easy or pleasurable, but sometimes it's actually about taking risks and pushing the boundaries to know what is possible and to explore things that might feel scary or perhaps embarrassing or uncomfortable. So somatic ethics in this artistic project relies a lot on the choreographer's sort of caring orientation and her habitual ways of relating to herself and others and her materials. And by deepening our own somatic awareness and sensibilities, we as designers can also cultivate such a caring orientation as we shape the interactions and movements that will invite our future users to engage in with our technologies. So through engagement with a som-aesthetic perspective on ethics in design, we can uncover and probe what types of movements that lead to somatic awareness and care in how we relate to ourselves and others, but also to design for enactments of bodily freedoms as well as increased aesthetic experiences and expressions. Thank you.
Thank you very much for your talk. As I mentioned earlier, for people who joined later, this paper got a honorable mention, which is only 5% of the top Chi paper, so this is fantastic. We don't have diplomas to hand out, obviously, but hopefully you will get them in the post. But that's great. So if you have any questions, could you please put your name into the group chat? We have about 10 minutes for questions, so any question you have. Okay, I think we'll do like for the last, this relationship between the human and the machine here, because it feels almost as there's a strong emotional connection happening as the person moves and kind of expects the drones to follow, but also a generation of technology that we want to create. Did you start thinking about it? Was there anything in your findings that would like kind of orient us to what do we need from drones?
Oh, thank you so much for that question. It's really interesting. And it's a difficult question, but
sorry.
no, that's okay. It's good. So I think, first of all, the situation that we have looked at here, or the context that we have studied, is an artistic process. So she wasn't, it was actually really important for the choreographer that the drones, how do I explain this? It actually helped her and inspired her that the drones had their own behaviors, and that the fact that she also had to adjust to them. So that sort of resistance and friction actually brought something for the choreographer here. And I mean, of course, so the question is more maybe where, how much of their own sort of ways of moving, and how big can the delay be before it breaks down, and when is it just enough to be sort of evocative and help the choreographer? So, I mean, obviously we can't have like drones flying around that don't respond at all, and we have to, I don't know. So I think the question is more like, when is it a failure and when is it actually, bringing something to the interaction? And I think that's really difficult and something that you need to explore in the design process. So it's not just about making, things work completely seamless. Yeah.
Yeah, for sure. I think the question was also like, can we learn from this to think about the next generation of technology? Because, it doesn't have to be a quadcopter flying in the way it is now. We could imagine very different flying behaviors. And I feel this is almost inspiring in terms of how do we design the next drones to support this type of interaction. Antti has a question.
Okay.
Thank you. Very interesting work. This reminds me about one of the talks that we heard also yesterday that was given by Svanaes about robotic ears. There was this kind of a presentation where he described a system where an actor or person could control ears that were moving like this, and the drones and the ears, they are both type of artificial limbs, things that extend your body in a way. And learning to control something which is not originally part of you but becomes part of you through experience is a kind of interesting process. So can you share anything about your observations about this process of first being kind of not familiar with the new kind of a bodily extension that you have, and after a certain amount of experience becoming able to control that? Were there certain kinds of stages, and how did the actor or the choreographer kind of describe this kind of this process of becoming more experienced and competent?
Yes, thank you so much. That's a really interesting question, and I can also talk from my own experience here, because I interacted quite a lot with the drones. And I mean, I hope you could see in one of the videos I shared, when you haven't moved with the drones, if it's your first time or if it's like your first few times in a long time, it's really difficult to move with them because you're really preoccupied with how they are going to respond to your movements. Are they going to take off and crash into a wall? Are they going to crash into you? And this is even though you know the system is actually safe and you know it won't actually crash into you. You're really scared because you don't want to break the drones and you don't want to get hurt and you don't want to hurt someone else and you also don't want to break the performance. So you become really like preoccupied with how you move and how the drones respond, and you try to calculate the responses and movements all the time. But as you sort of you develop a sort of perceptual understanding of how the drones are reacting, which lets you start improvising with them, and you sort of lose the focus on trying to calculate your movements and responses, and you start to be able to sort of move with them and sense them and engage in the dance, you know. So I'm not sure how to explain that in stages, but it really requires you to actually be there in practice and move with them. You know, it's not something that someone can tell you how to do, or well, you can get pointers like I did with the choreographer, but like you have to just you have to practice with them.
Thank you.
Great. We have a question from Barry.
I shouldn't really ask a question, but I'm going anyway. So where's the audience, right? So you focus, I guess, on this bit before, which is fair enough. But you're talking about like an ethics of creation as part of an artistic performance. Now, what about the connection between that and the kind of ethics in our creation? Because it seems to me in an artistic performance, the most interesting things to watch, certainly if we think of operas, are the very unethical, or the, you know, drama comes not necessarily from, you know, ethics in a sense of like, you know, the good in some way, right? So I kind of feel a bit unsure about these links that you're making there from artistic performance to kind of creation.
Can you say the last bit again? Sorry.
Yeah, then making the link between ethics in the in an artistic performance and ethics in the kind of creation that we make in our things we're building.
Yeah. So I think so. There were a few things in this question, but first of all, if I start from the audience, I think that's actually something that a future study would have to explore a little bit more, because we didn't actually engage with the audience at all here. And for the choreographer, obviously it's really important that, I mean, she's trying to create an experience where the audience feels something, but in the process that we followed, perhaps the most important thing is actually what she wants to express. So that's sort of perhaps a little bit more important for her than the actual reaction of the audience at this point. But and then, like you say, I think, like you even say in your question, it's not actually about what's nice and good all the time. I mean, it can actually be about, you know, feeling sensations or scary or the drama or the so it's not about like determining whether like something is good and nice or bad necessarily. I don't know if I'm answering your question, please. Okay.
Great, thank you so much, Sara. Everybody, if you can clap again, either physically or virtually. Thank you very much. It was really fantastic. Our next speaker is Veronika Domova.
Hello to everyone.
Welcome. So the paper is SwarmControl, user-defined swarm robot control. It also got an honorable mention, so congratulations as well. This is fantastic. And whenever you're ready, you can start sharing your screen.
Thank you. So I have pre-recorded presentation from my colleagues from Stanford. And then after the presentation, I will be happy to answer the questions.
Thank you very much. Veronika, do you want? Okay, so I'm trying to see if there's any questions. So once again, if you have any question, please put your name in the chat. So Carla has a question.
Hi, Veronika. Nice to see you again.
Yes, the same. Long time.
Yeah. So I love the presentation. I did some work myself on user-defined gestures some time ago, and I thought it was funny how to see that even though this is for swarm robots, which has nothing to do with like touchscreen gestures, there were so many similar results about, for example, legacy effects or cultural background on how people define their gestures. So I have a couple of questions. One is that I found quite interesting to see that people came up with multimodal gestures. But in general, you suggest that, for example, there should be a focus on gesture, but sorry, like let's say multimodal commands. There should be a focus on gesture, but maybe also integrate verbal commands or other modalities. I was wondering if from the interpreter point of view, it would be enough to understand a command from the gesture only, for example. How would you take advantage of the extra modality of what would be the advantage of really combining a gesture with a verbal command, for example?
Oh, that's a really interesting question. I think that, as you pointed out, people were, let's say, making gesture. Let's say when they wanted to push away the robots, they would make this kind of gesture. But at the same time, they would maybe add some emphasis how they want the robots to do it. For example, okay, move faster, faster. So they will add a bit of extra tone, how they expect the robots to move. So maybe in addition to the actual action, what you want them to do, you want to get some extra note on how you want the robots to move, because they can do it faster, slower, you know, maybe in a more organized structure manner, or maybe more chaotic. So I see, for example, one point can be this, so extra value in tracking the voice commands, because some of them were, you know, I think people were not even noticing that they were also saying something. So they were focusing on their gesture. For example, they would point and like, come here, come here. So they would be like, even sometimes they would sound kind, and maybe sometimes maybe a bit more rough. So that was interesting. So maybe I think that you can get some extra knowledge how the robots exactly should behave, because there is like a, you know, a spectrum of possibilities how exactly the robots do this or another action.
Right, that's super, super interesting. And I also was wondering if you, so I know that this was an elicitation study, but I'm not sure if maybe the goal is to understand what would be an ideal set of interactions with the swarm robots, or if you are also thinking of ways of allowing for more individual differences in how people want to interact with them, like how to allow each user to define how they want to enact their commands, and what would be like the main challenge there?
You know, I think it's really interesting, and I had the same questions when I was participating in the study, that people are different, some are more verbal and some like more gestures and so on. So for sure, if you want to develop like a commercial system, you probably would encode all possible interactions, like as much as you can, and include all possible sensors, whatever also allows your budget or technology, and probably allow people to configure. I'm not sure, I'm just speculating right now. But another important point, I think, is the context. So what is the context where you use this robot? So maybe even if you're more verbal person, let's say you prefer to talk, but your environment is maybe loud, you know, you cannot talk because it will be a lot of disturbances and so on. So then you have to compromise and let's say force the users to maybe use gestures. Again, I'm speculating here, but I think the context is important, and also what is the task that the user is trying to achieve, because we try to run the study in a more general form, just try to illustrate a general interaction, context independent, but I think context would matter a lot here, environment also in general.
I see, that's very
Thank you.
interesting.
We have a couple more questions. Kia is next.
Yeah, so I will leave my spot to Hannah so that she gets time to ask her question. Mine was just on theory. I thought that this was a lovely paper, but it seems like it was there's a need for more theoretical foundations to understand what kind of gestures and body language that we typically engage in. But so I'll leave my spot to Hannah instead.
Well, we have a break after, so I think we can go a little bit over. So if you want to ask your question and get a discussion.
Yeah, so my question, I was trying to quickly look up your paper to see what theoretical foundations you have for understanding body movement and how we create meaning from movements.
Yes, thank you for this comment. So as you pointed out, so we relied on existing literature. We looked at what other authors used, maybe in somewhat similar studies, which gestures they used. I think that was the main approach. But maybe
so not really any sort of coherent theoretical foundation, because this is where I'm thinking maybe there is a role for us who work with these kinds of body-based interaction, that we need to start explaining what's going on with meaning-making processes and how that is happening, because there is a lot of stuff here that we, as we move on, there will be more and more systems like this. So, but I was super happy to see this, and I love the swarm. I haven't seen that many swarm interaction studies before, and so this was amazing. So very happy to see that, but looking forward to more coherent theoretical work that we can engage with together.
Thank you very much.
Hannah, you're next.
Yeah, thank you so much. This was really interesting. And so nice to see you, Veronika.
Yes, hello again.
Yeah, so I've been wondering about the verbal commands that you mentioned, and kind of, in a sense, relating that back to the failures that we've heard before at the beginning of the session. Do you think that sort of like, is there sort of like a temporal relation, that gesture is sort of like first and then verbal comes if something is like not happening as you said, like as fast as it should, or sort of like a specification of or correction of the gesture? Would you say that there's something in that direction?
Maybe both, actually. Maybe one reason for extra verbal was also the setup of the study. We used partial Wizard of Oz, so that we pre-programmed the movements of robots, and then we saw when the user would stop their command, and then we run the actual action, right? But sometimes there was some delay. It was not really clear. Did the user stop the interaction or not? So that, for example, we would wait a bit more, like add some extra gap between like the user stop, let's say, moving with his hands and so on. So then the user would think that, okay, the robots misunderstood me. And then he would do the gesture again, maybe more intensively, and maybe add some extra words. So maybe this was one of the reasons for verbal, but I think in general it's also natural that when we interact with the robots, even our home technology, we tend to say something sometimes. Let's say this like small vacuum cleaners that we have. I saw people would like treat them a bit like animals and start talking to them like, okay, come here, even if the robot is not even coming itself. Let's say you're carrying it, but you at the same time you would still say, okay, come here. Like, so it's maybe part of our, I don't know, mental model in a way, how we want to interact with the robots. So we do something, and plus we add some extra words on top of that. Yeah, that is an interesting question. I think maybe more studies could clear this. Why exactly people add something on top?
Interesting. Thank you.
Great. Thank you very much. So it doesn't look like we have any more questions. Thank you very much, everybody, for your time. The next session is in 15 minutes at 10:45. And in this room, it will be one about sensing, and the other two are going to be about design or learning in games. Thank you very much to everybody who presented and to everybody who asked questions and came.